Hi everyone, welcome to the Ultimate Calculus Guide. In this series, we explore limits, derivatives, and integrals step by step, like a dictionary of rules. Each lesson of this series focuses on a group of related functions. And in this video, we will see how to take the derivative of polynomial functions. And we have 5 examples here, and the first one, 2, 3, 5. Okay, we will take the derivatives of these functions all one by one. Firstly, to take the derivative of the first function, remember that when we have a constant in a derivative, constants does not change how the derivative works. Constants just stay alone for the right. Okay, then to differentiate for 3 times x to the 5, 3 will stay here, and you should also remember the derivative of power functions. When we take the derivative of a power function, the exponent will come here as multiplication and 5 times, and then we subtract 1 from the exponent to the power of 5 minus 1, and this will be equal to 15 times x to the power of 4. And here for the 2 times x cubed, constants doesn't change how the derivative works, so we write 2 here, and then exponent will come here as multiplication 3 times, and then we will subtract 1 from the exponent. Then the derivative will become 6 times x to the power of 2, x squared. For the next example, again, constants doesn't change how the derivative works, and we will write 4 here. And remember, x has a power of 1, and we will take 1 as multiplication here, and then subtract 1 from the exponent, and this will become minus 4 times x to the power of 0, and this is equal to minus 4. And 5, the derivative of a constant function is 0, so the derivative is 0. For the second part, when taking the derivative of a polynomial function, we consider each term separately and differentiate them one by one. We will take the derivative of x cubed, and then take the derivative of x squared, and then x, and then 4. Okay. All of these are power functions, so for the derivative of x cubed, we will take 3 here as multiplication 3 times x, then we will subtract 1 from the exponent and take 2 here as coefficient, 2 times x to power of 2, subtract 1 from the exponent, and the derivative of x is 1, and derivative of constant is 0. Then the derivative will become 3 times x squared plus 2 times x plus 1. And next problem. Okay. Next problem is this. When taking derivative of a polynomial function, we consider each term separately, and then we will take the derivative of 5 times x cubed, and we have a constant here. Constant doesn't change how the derivative works, so we will write 5 here. Then take the exponent here as coefficient 3 times, and subtract 1 from the exponent. And again, minus 3 is a constant. We write it here, and take the exponent as coefficient here, 2 times x to the power of 2 minus 1 plus 6x. The derivative vanishes x here, and the derivative will become 6, and the derivative of constant is 0 and this is 0. 5 times 3 is 15, x to the power x square minus 3 times 2 is 6x to the 1, and we don't need to write 1 here, and plus 6. The derivative will become this. Again, a polynomial function. Always remember, when taking the derivative of a polynomial function, we consider each term separately and differentiate one by one. We will differentiate this one and that one, and after this one and this one, term by term. And remember that constants doesn't change how the derivative works. So constants just stay alone for the ride. Okay, we will write first 1 over 5. Write 1 over 5. Then the exponent will come here as coefficient 5 times. Then we will subtract 1 from the coefficient. And then we will write the constant 1 over 4. Then the exponent will come here as coefficient 4 times. And then we will subtract 1 from the exponent. Again, we will write the constant 1 over 3 here. Then the exponent will come here as coefficient 3 times x to the power of, and we will subtract 1 from the exponent, and 7 times x. And here the x vanishes when we take the derivative, and this will become minus 7. 1 over 5 times 5, they cancel each other, and we have here x to the power of 4. And 1 over 4 and 4 will cancel each other. We will have here minus x cubed, and 1 over 3 and 3 will cancel each other. We will have x squared at here and minus 7, and the derivative is this. And this is our last example. Again, when taking derivative of polynomial functions, we consider each term one by one and constants will not affect the derivative. So take the exponent here as multiplication and x to the power of 6 minus 1 minus constant is 4. Take this 3 as coefficient here, 3 times x to 3 minus 1 plus, and 3x. When taking derivative, x vanishes and this will be equal to 3, and the derivative of a constant is 0, and this is 0. 6 times x to the power of 5 minus 4 times 3 is 12 times x to the power of 2 plus 3, and the answer is this. And see you in the next video.